In this video, I want to talk about writing an equation that models variation. So you may have heard some of these terms before, I'm not sure, but let me explain what they mean. So direct variation is a term that means that two things are related in a direct way, or they have a direct correlation, we sometimes say. It means that when one goes up, the other one goes up. This is like studying, time spent studying and your final exam grade probably has a direct variation, right? When one goes up, the other one goes up. The more time you spend studying, the better grade you get. That's a direct variation. And there's a general equation that kind of can always tell us what a direct variation looks like. And it's y equals k times x. So x and y are the two variables. When one goes up, the other one goes up. K is just what we call a constant of proportionality. And a constant of proportionality just tells us how much the one goes up when the other one goes up. So in the studying for a test example, you might not expect that for every extra hour you study, you earn 1 extra point on your final exam. I would hope it's a little bit more than that, right? So for every extra hour you study, I hope you would earn 2 or 3 or 4 or 5 or 10 more points on your exam. Probably 10 is a little bit too high. But in any case, we need to remember that, so the constant of proportionality is just whatever it is that makes that proportionality work correctly. How much does one go up when the other one goes up? That value is k. Okay, so that's direct variation. That's when one goes up, the other one goes up. Inverse variation is what you might guess. It's the opposite of that. When one goes up, the other one goes down. Okay, so if you have an inverse variation, when one thing goes up, the other thing goes down. And so the equation that we use for that is y equals k, there's always a k, times 1 over x. Or you can also write this as y equals k over x. So 1 over x is the way to say when this one goes up, then this one goes down, or when this one goes down, then this one goes up, right? Because as the denominator of a fraction gets larger, the number actually gets smaller. Again, k is just the constant of proportionality again. That just tells us how much does one go up when the other one goes down. So this is the general equation for an inverse variation, where when one goes up, the other one goes down. Okay, and then last we have a joint variation. So a joint variation is when one thing depends on two things, or when one thing is affected by two things. So if we said y is equal to k, of course, times x times z. This would be if it would be varying jointly, so y would vary jointly with x and z. Meaning that when these two go up, then this one goes up. And so yeah, varying jointly means that x and z both make y go up. So basically, joint variation is kind of oversimplification, but it would be like when two go up, the other one goes up. that's a little bit of an oversimplification because obviously sometimes like this one could go up and this one could go down. It gets a little bit more complicated, but that's basically the idea. So joint variation is when y is equal to kxz. Okay, so let's do an example or two or three probably. Oops. Sorry, forgot to delete that. Okay, so let's do an example. So our example is y varies inversely with x with a constant of proportionality k equals 2. Okay, so we want to write the equation. Okay, so y varies inversely with x, so that means it's going to be y equals k over x, and then with a constant of proportionality, k equals 2. So it would be y equals 2 over x. Now sometimes they're going to give you what the constant of proportionality is, and sometimes you won't know and you'll just leave it as a k. So whatever you're given is what you should do. Okay, so let's do another example. U varies directly with V. Use K for the constant of proportionality. And write the equation. Okay, so it says U varies directly with V. So that means that U is on the left-hand side of the equation. So direct variation is just K times the other thing, which in this case is V. And it just says to use K for the constant of proportionality, so we would be done. Okay, let's do one more example. Okay. Y varies jointly with V and the square root of x. Use K for the constant of proportionality. Okay, so this one says y varies jointly with v and the square root of x. Use K for the constant of proportionality, and we need to write the equation. Okay, so this is a little bit trickier, but it says that y varies, so whatever varies should be on your left-hand side. And then it says with v and the square root of x. So when something varies jointly, we just multiply them, and then we always need to multiply the constant of proportionality, and that's it. So I know that these sound complicated, but if you kind of break it down, you're just sort of putting them into the model that we learned in the beginning.